how do you pick the right value of k? K will affect the performance of the algorithm a lot, and here we're looking at classification again. So we have two different classes, the red and the blue. They're represented by two attributes, x1 and x2. And we're trying to predict what green is. So depending on what value of k you pick, you will end up with different classifications. So if k is equal to 1 or 2, or 3, you will classify it as red. If k is equal to 4 or 5, you will classify it as blue. So as you vary k, your classifications will change, and in general, k has a pretty strong effect on performance. So what happens if you pick small values of k? If you pick small values of k, you get the problems that we discussed about with variability of the decision boundaries. Small changes to the training set will result in massive differences to the decision boundary. So you will classify new data differently based on tiny perturbations of the training set, which is not good. So it's a high variance classifier. If you pick a large value of k, you of course make it stable, but there is a point at which you will make it too stable. As we said, if you make k too large, maybe if you take k to be all the instances in your training data set, then this will just predict the class which is the most frequent class a priori. So it'll be like the prior classifier. So both of those are undesirable, and you want to pick something in the middle. So how do you pick something in the middle? You use cross-validation, and here it's critical to use a separate validation set. So you take your training set, you're going to rip out a small portion of it, call it a validation set, and then use that validation set to evaluate different possible values of k. So the way it's going to work is, for this validation set, you're going to predict the label for every instance in the validation set using kNN with k equals to 1, kNN with k equals to 2, kNN with k equals to 3, and then you look at what value of k gives you the best performance on the validation set. And you're going to take that value and use that as the final setting of your algorithm. So you're minimizing the validation error. Now, I said it's critical that you use a separate validation set. What value of k would you get if you didn't use a separate validation set? So if you use the training data as your validation data, what value of k would be optimal? 1. So take a moment to convince yourself that that's the case. It's 1 because for the training data set, there's always going to be one example which is nearest and has the correct class label, the example itself. It is no longer guaranteed if you take, say, 3 nearest examples, right? Because you could have a blue class and then the other 2 could be red, so you would actually misclassify it. So so if you don't use a separate validation data set, this procedure will always say 1. So it's critical to have a separate validation set.